Today we are about to discuss about part B, sixth lab program. Hope you are all practicing simultaneously lab programs also, right? Okay, right. The lab 6 of part B. This is the last program in part B, sixth. Okay, so we'll simulate the transmission of ping messages. Ping is nothing but it is we have already seen. It's a transmission control protocol. So ping will not have any what do you call uh, acknowledgement. It is a UDP. Okay, and this ping message we will discuss over network topology consisting of 6 nodes. And ping, what it will do, it will go and hit the target machine, and the response will come back. We have seen ping, we have seen in the previous class also. Okay, and okay, it will once it comes back, what is the total time that is taken to go and hit the target and come back, so that is, we call it as round trip time. So we have to find the round trip time. So that was the question. So question, we have to have 6 nodes. So meanwhile, before actually I start this explaining this program, let me show first a demonstration. So that you people will understand what is exactly, how exactly ping will work, and finally what is round trip time and all. You will certainly understand, and later if I explain the program, probably you will understand better, right? So the virtual machine is about to start. Okay, okay, remind me later. Okay, right, full screen, done. Okay, since I've added connect to virtual machine, yes, right. The pen drive, in the pen drive actually I have stored the program, so that is the reason I am just taking it. Yeah, it is already there. The program is already there. Just close, quit. Okay, lab 6b.tcl. Just copy it, and in the desktop we have CN lab. We have CN lab, and in this I'll just place this program. Okay, I just place this 6p.tcl. So now go to command prompt. So okay, we went to command prompt. Here yes, okay, here, right. One second, I just close. Yeah, now what I do, I go to desktop and CD CN lab, and here ls. Our program is here. So that is 6b.tcl. So gedit lab 6b.tcl. We'll see this program. I have already typed all the program contents. Yeah, program contents I have already typed. Okay, and finally it is printing the total. Put as round trip time is so and so milliseconds. It is just printing. Okay. Anyhow, the program is ready. We'll explain the program later. Now, ns lab 6b.tcl. Once if I run, okay, line number 3. So 2, 3, right. So what I'm doing, I'm just removing all the white spaces. So that if there are any, characters, hidden characters, so that will be removed. Okay. Right. Since I have copied from the PDF, so there are chances that we may get some additional white spaces. I'm just saving it. Once saving is done, just quitting out. Okay. Right. So yeah, round trip time is 151.2 seconds. So the result has come, but the simulation is going to come now. You can see simulation is about to come. So 6 nodes, they have said 6 nodes. 6 nodes are arranged in order. Now I run this. Automatically, simultaneously, the nodes will go and hit and come back. The packets will go and hit and it will come back. You can see the round trip time. Round trip time, it took around 151 seconds. Okay, so here you see, yeah. Okay, there is, right. So this is, and during ping, the message used to go simultaneously. Once message used to go simultaneously and hit the destination and come back. So that was the ping. And in the first case, what we did, we simultaneously started. Okay. And later in the second case, individually we started. 0 will send first, later 5 will send first. So in the both directions, we are finding the ping. What is the round trip time? The same round trip time, it has been calculated here. It is actually 151.2 milliseconds. It is calculated and it is displayed. Okay. So node 0 received a ping answer from node 5. Node 5 received from 0. Node 0 again received from node 5. Node 5 received from ping from node 0. So either you do 0 to 5 or 5 to 0. So the same round trip time, we are just finding it. This is the program that we have encountered. This is the program that we have encountered. So now what I do, I just run it again. and I hold the snapshot of this program, and this will certainly help me while I'm okay. Okay, while on the desktop. Okay, I'll save it. Lab 6B. Okay, I save it. So same screenshot I'll be using while explaining. So hope you will understand better. Okay. So what I'll do, I'll just copy this screenshot image. Copy to. Okay, copy. Okay, I'll just copy it. Put it in pen drive. Okay, put it in pen drive. So image is there. I just close this pen drive here. Okay, and I connect the pen drive to the Windows. So remove the device. Okay, remove the pen drive and disconnect and connect to the host. Host means it will connect to Windows. Here, okay. So before I proceed, I'll just I just open this. Continue. I take that particular image. That is lab 6. Yeah, this is the image. Just copy it and I put it in the PowerPoint presentation. Right, I put it here. Here, actually here it is very much essential. Paste it. So I don't want all these additional thing. It is blocking. So I want only this much. Yes, only this much is sufficient. Sufficient. Yes. Done. So I'll just put it here. Right. Same thing. I put it in the next slide also, so that we get easily understood. Okay, right. Okay, fine. We'll run our slideshow. So in the program, so now we have seen the output of the program. Now, what we'll do in this program, we will first create 6 nodes, and we'll have a model to have a ping message, and we'll find the round trip time. Okay, first of all, we create a simulator object. Later, we open the trace file and NAM file. We'll call this as a NAM file as NF, trace file as ND. Okay, trace all. So you can change, and we define 2 colors. One color for red, another color for blue, and so color 1 is for red, color 2 is for blue. Right. Further, what we'll do, we'll create 6 nodes. Set N0, N1, N2, N3, N4, N5. So all 5 nodes are created. That means 6 nodes are created. Right. Now, these are connected with links. Okay. Duplex link between 0 to 1. Yes, with the 0.1 Mbps. And 1 to 2, 0.1 Mbps. 2 to 3, 0.1 Mbps. 3 to 4, 1 Mbps. And 4 to 5, 0.1 Mbps. So all it is connected. And it is a duplex link. Duplex link in the sense you can send simultaneously from a source to destination and destination in both the direction. You can send simultaneously together. All right. Next, this is new. You observe, this is new statement. which you have not seen in the earlier programs. Duplex link, OP means option. Okay, N0 and N1 oriented towards right. That means N1 is oriented towards right. So the meaning of this statement is, so N1 is present to the right of N0. Yes, N1, that is, this is present, N1 is present to the right of 0. So it is presented to the right of 0. That is the meaning. Right. Next statement. N1, N2 is oriented right. That means N2 is present to the right of N1. So that is the concept. N2, this node is present towards right of N1. So that is the thing. Next, N2 and N3 oriented down. That means N3 is present oriented in the downward direction. That means N3 is present downward of N2. Yes, that is that. Next, N3 and N4. N4 is present oriented in the left, oriented left. That means N4 is present here in the left, okay, of N3. So that is that. Next, N5 is oriented towards left. Yes, same. So this is what you have to understand. So in the previous programs, what we used to do, we used to click on edit and we used to edit it. So here it is, editing is not required because the position orientation also we have specified. The orientation is also specified so that the entire model you can easily understand how exactly they are connected. Right. Now, we will write a receive function which is ping, agent ping. RECV is a function, it's a built-in function. So agent ping, okay, which have a instant procedure called RECV, which will certainly return RTT. RTT means round trip time. So what we are doing, so it is having self is nothing but it's a current pointer. This pointer is pointing to the node where it is actually you are starting the ping, right? Next, put as node ID. Node ID is nothing but the current node receives the ping answer from, it is displaying from $from. $from is the node which you are targeting. So that is target, and round trip time is automatically calculated. RTT is automatically calculated. So you can certainly see RTT is automatically calculated and displayed. So this function, RECE function, is a built-in function. What it will do, it will create first instant variable called a node, and that node is nothing but node underscore is nothing but the starting address of the node, starting address of the ping, and from is nothing but, so this is the target. So target means the final destination. So it will go from this start and it will go to end. And what is the round trip time? So here starting will be 0, node underscore is 0, from is nothing but $from is nothing but it is your targeted. So from target, if you move a ping message, so ping message will start from here 0, it travels all the way and reaches 5 and moves back in the same direction to reach the source. So the entire time we call it as round trip time, and round trip time is automatically recorded and it is being displayed here. Put s, that's why we are using put s. It is displayed, right? Now, after this, what we are doing, we are creating two ping agents. So we'll call it as first ping agent as P0. P0, just like we have UDP protocol, we have TCP protocol, we have FTP protocol. Just like that, ping is also a protocol. Okay, ping is a protocol. Set P0 as new agent slash ping, and attach ping 0, P0 to N0. That means N0 becomes the starting of the, starting address is N0. N0 is the starting address of the ping. That's why we are attaching ping to the starting N0. And we are setting ping zeros, format ID is equal to 1. 1 means which color we have seen in the earlier, right? 1 is nothing but it's in, I think it is there in red color, I think. 1 is red, 2 means blue, right? So 1 is red, 2 is blue, right? So the same thing. So we are setting for ping, whatever the ping message that it sends, it is in the form of red color. So, and we are setting another ping P1, we are calling it as P1. P1 is attached to N5. So N5 is nothing but the node 5, and its color is FID. That means format ID. P1's format ID is 2. 2 means blue color. So first ping color, that is P0's color is red. P1's color is 2. We are doing 2 means red. So connecting these two agents, connect P0 comma P1. So that means you are connecting starting ping and you are connecting the ending ping, right? So once they are connected, what happens? You write the finish. You take NS and NF and ND. NS is for network simulator object. Object. NF for animation file, and NAM file. ND for trace file. So we flash all, stop recording, close NF and ND. So we used to do the same thing in the previous program. Only name is changed. That's all. Okay. So we execute the NAM file and we exit. We close. We are doing nothing, and we are setting the current time as 0.01. And now is nothing but present time. Present time is whatever the time that is executing. Now it's exactly 11 o'clock 47 minutes. So 11 o'clock 47 minutes 00 seconds, something, whatever the seconds that is at the time of execution, it will be recorded in a variable called now. Why this is required? Because you have to find the round trip time. So for finding the round trip time, you need require. So exactly at the current time, you start peaking 0. Exactly at the same time, you start P1. So simultaneously, you send P0 also, you send P1 also. Send simultaneously. And exactly at 6 seconds, you send P0. Exactly at 8 seconds, you send P1. So this is first time. Both are sent simultaneously. This is sent after 6 seconds and after 8 seconds. 0.6 and 0.8. It is sent. Now at 1.0, that is exactly 1 minute, you stop the entire operation, right? That's the thing. Okay, so that's all for the program. So when it sends the ping message, what happens? It will display the animation, and it will display the time taken. So the time taken is irrespective of either you send from 0 to 5 or 5 to 0. It is the same time. Both are sent for the first time. Both are sent. So in this first experiment, both are sent simultaneously. In this experiment, individually, independently sent. In all aspects, in all other cases. So what happens? The final output, what you are getting is 151.2 seconds. mathematics. Same thing. So that's all for this class, lab class. So your entire explanation of this particular program is available in this website, and also the study material, the lab manual is available in this website. That's all. Thank you. Have a wonderful day.